Have you ever wondered how your favorite game keeps track of your score? Or how a banking app knows your balance down to the very last cent? Well, it all comes down to a few simple, really fundamental building blocks in the code. Today, we're diving into the absolute bedrock of Java, the 8 primitive data types. Think about it. Everything you see on a screen, your high score, your name, the price of something in your cart, it's all just information. And a computer needs a way to hold on to all that stuff. It all starts with just a handful of simple but really powerful tools. And those tools, they're called primitive data types. They're the simplest, most direct containers for information that Java gives us right out of the box. Think of them less like complex structures and more like raw, simple values. Let's meet them. Okay, first up is the group you're going to use all the time, the integer family. These are pretty much the bread and butter of your code, and they're designed for one specific job, handling any number that doesn't have a decimal point. So, if you need to store a count, like how many lives you have left in a game or the number of items in a shopping cart, you'd use one of these. But here's the cool thing. Java is all about efficiency, so it doesn't just give you one option. It gives you 4 different sized boxes to make sure you use exactly the right amount of memory you need, and no more. And you can really see that trade-off right here. A byte is tiny. It's perfect for small numbers. A short gives you a little more breathing room. And then an int offers a really massive range. And that choice, it's a classic engineering problem, right? A smaller box saves memory, but a bigger box can hold a much, much larger value. Honestly, for most situations, I'm talking 99% of the time, int is your go-to. Its range is huge, over 2 billion in either direction, which is more than enough for the vast majority of tasks. You'd only really reach for a byte or a short in really specific cases, like if you were creating a gigantic array with millions of values where every single byte you save actually makes a difference. And here you can see the whole family, including the absolute giant of the group, long. Yeah, it uses twice the memory of an int, but it can hold a number so unbelievably vast, you'd need it for things like scientific calculations, measuring distances between galaxies, or, tracking time down to the nanosecond. So we've covered whole numbers, that's solid. But what about all the values that fall in between? Things like prices or scientific measurements. For that, we need to shift our thinking a little bit, away from just the size of the number and towards its precision. Right, so for any number that needs a decimal point, like 3.14 or $19.99, you're going to use one of Java's floating point types. And there are 2 of them, float and double. Now, the key difference here is all about precision. A float is smaller, it saves memory, but it can start to lose accuracy after about, say, 7 decimal digits. A double, on the other hand, gives you about 15 digits of precision. That might not sound like a huge difference, but trust me, it's massive when you're doing sensitive calculations where tiny little errors can multiply and cause big problems. And that's exactly why double is the standard. It's the default choice for pretty much any calculation that involves a fraction. Unless you have a really, really good reason to save those 4 bytes of memory, just sticking with double is by far the safer bet to avoid some really unexpected and frustrating rounding errors. But, and this is a huge but, here's a critical warning. You should never, ever use float or double for money. Because of the way they store numbers behind the scenes, they can't perfectly represent certain decimal fractions, and that can lead to tiny inaccuracies. For any financial code where every single cent matters, programmers use a much more specialized tool that's built for perfect precision. All right, so we've covered the 6 types for handling all kinds of numbers. The last 2 primitives are different. They're the specialists, each built for a very unique but totally critical job. One's for logic, and the other's for characters. First up, we have the boolean. It is the simplest data type of all. It's almost more of a concept. It can only hold one of 2 possible values, true or false. That is it. It's just a clean, simple binary switch. But don't let that simplicity fool you for a second. The boolean is arguably the most powerful type of them all, because every single decision your program makes, if the user is logged in, if the player has lives left, if the item is in stock, all of that is controlled by a boolean. It is the absolute foundation of all logic in software. And our final primitive is the char. It's designed to hold just a single character. This could be a letter like A, a digit like 7, or a symbol like the $sign. The key is it's always just one character, and you always write it inside single quotes. What's really cool is that the char type uses something called Unicode. And what that means is it can represent characters from pretty much every written language on Earth. So we're talking about the English alphabet, sure, but also Greek letters, Japanese kanji. A char is a tiny little container with a truly global reach. So there they are, the whole crew. 4 integer types, 2 decimal types, and our 2 specialists for logic and text. So which one do you choose? Well, that's one of the first real decisions a programmer makes when writing any piece of code. So let's boil it all down real quick. For whole numbers, just start with int. Only pick a smaller one if you have a very good reason. For decimals, always default to double to protect your precision. And for those special rules, you'll use a boolean for every true or false decision and a char for any single character you need to work with. And this matters, it really does, because picking the right tool for the job is one of the first hallmarks of a professional developer. Using a massive long where a tiny byte would do the trick is just inefficient. And these small choices, when you make them hundreds of times in a big project, they have a huge impact on your code's performance and how much memory it uses. Integers, decimals, characters, and logic. That's it. From the most complex 3D game engine to the simplest little mobile app, absolutely everything is built from these 8 simple tools. They are the foundation. So the only question left is, what will you build with them?